Hey guys, I'm sitting at my desk here, which is a little bit crowded with a lot of the side projects that I'm getting involved in the construction of this airplane. But the main reason I'm here today is that I wanted to share with you some of the things I found out about the actuator that I bought for the landing brake. Basically, this is what will activate my landing brake. It will make the landing brakes go down underneath the belly of the airplane and will bring their landing brake back up. This is an electrical unit. Obviously it's running on 12 volts. I bought it from servocity.com. The unit number, actually I have it here, it's HDA 4-50, and it has a travel of about 4 inches. I know that in the past they were recommending 6 inches. By the time I figured out, I already bought a 4 inches unit, so a lot of friends of mine have used a 4 inches unit, so I don't think it's going to be that much of a problem. This is a pretty strong unit. I think it has a 300 or 500 pounds holding power, so that should not be a problem in any way. It takes about 10 seconds. It's not the fastest thing around. It takes about 10 seconds to go up or down the 4 inches, but I think I can live with that. The few things I wanted to show you today, one of them is the attachment that I made for the back seat. So this will attach to, I'm sorry, not the back seat, but the back side of the pilot seat. So I made this bracket, and this will attach, you know, the front seat is at 45 degree angle, so it will attach like this with fiberglass and flux, and the jack itself will run down through the floor of the rear compartment, and it will attach to the speed brake right here, or landing brake. The hinge for the landing brake is here, so this will actually move the landing brake up or down in this fashion. Now, one of the issues that I had, and by the way, don't look at all these washers. I don't have the correct bowl, so I just ordered some. So right now, for the time being, I used a bunch of washers. But aside from that, one of the problems that I was contemplating a solution for was the fact that I would like the speed brake to be able to be somewhat adjustable, because sometimes the speed brake might not come all the way up. It might have a little gap, and I would like to be able to adjust the run of this unit so that I can suck up the last maybe quarter inch or half inch and make it completely flush with the bottom of the airplane. I had a few ideas. Chris shared with me his idea, and what he ended up doing, he had a different unit which is easier to work than this, but what he did, he took a cap off here, this does not have a cap, and put a rod end here, which is adjustable, and that's a fine way to do it. When I looked at the price of the rod ends, they were a little bit on the expensive side, and I couldn't quite figure out the one that I wanted, so I kind of shelved that for a while. The other idea that I had to make this somewhat adjustable was to be able to slide this unit up and down, and what I was thinking about doing was to make this as slots. I don't know if you can see them right now, they're holes, but I was thinking about slotting the holes, and this will give me about half-inch adjustability, about quarter inch up, quarter inch down in the position of this bracket up along the back seat, and that would help somewhat, but I was hoping for a little more range than that. So playing around with this, I found something that is really cool, and that you can actually turn the actuator arm, and it will actually adjust up and down quite a bit, I think about half an inch, and that's what this video is all about. I'm going to show you how this works. As you can see, right now it's all the way screwed in, and it runs about, yeah, let's call it about nearly an inch, 990, and you can unscrew this. It takes about 20 turns to unscrew it, and let's see. Alright, let me screw it in once, it's solid, and when you unscrew it, it goes up to 153 something, so about half an inch of adjustability. And just to show you what's going on here, it's got a threaded section there, as you can see. That it might not be in focus, but well, and there's a screw right in there. I don't know if it can be seen or not. So anyways, we're gonna run it up and down a couple of times. Okay, so I have it on the highest setting here, the longest setting, and I'm gonna actuate it using a little power source here. I'm gonna make it retract and extend, and we'll see how it works out dimension wise. Alright, so that's there you go. So we're gonna extend it all the way, so you can see it this way, and see what the dimension is for the max travel. Looks like about 5.410 or so. And switching the leads here on the cables, you can bring it all the way back down to the previous setting, which was about 133 something. Now same thing, if I screw it all the way down, now I have the shortest throw of the actuator, and again it's about 7.6 or something, and I can run it all the way up to an extended length of 4.847, give or take. And when I run it back down, it goes back down to its original around 7.7 something. So having 20 threads to go between fully in and disconnected, I can turn it about 10 turns, so be 10.5 turns. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see, we're rounding about 106 something. And this way I have a little bit of adjustability in either direction, so if should the speed brake, the landing brake, become too tight as it's being sucked up by the actuator, I can actually lengthen the rod here and loosen it up so that it won't end up breaking some fiberglass. And should it hang down a little bit for whatever reason, I can screw it back in, reconnect it, and then we'll kind of pull it up nice and tight. And the main reason I want to show this is because there are some units that do not behave this way. And I was talking to Mike, my friend, and we were trying this same thing on his speed brake, and what was actually ending up happening is that he was turning the actual screw, so you're actually basically running the motor by hand, and he was always going back to the original dimensions. He was actually not adjusting anything. So needless to say, I'm pretty pleased that this is the way this actuator works. I paid $130 for it, and yes, it is a little bit slow, but I'm kind of glad I will not have to do any fancy machine work to get this unit to adjust and fit properly onto the back side of the pilot seat. Anyways, I hope you liked it, and I'll be sure to take some pictures when it's all installed, and maybe run a video of the speed brake opening and closing. Landing brake, I should say. Thank you. Take care. Oh yeah, I just forgot to mention something that is actually pretty cool. and I did not know this when I bought the unit, but normally an actuator like this, there's two power cables. You send power 12 volt in one direction, and this extends, switch them over, sends it the other direction, and this retracts. So two cables is usually all you need. But as you can see, this unit has 5 cables and 5 wires, and the yellow one I kind of knotted it so I don't accidentally use it. That's just not important. But the cool thing about this actuator is that inside the unit there's actually a variable resistance, a potentiometer if you wish, that as the shaft moves up and down, it actually changes the resistance of the unit, electrical resistance I should say, as measured on these 2 wires. So I'm gonna hook it up and show you. This is about a 10 kilo ohm unit, so it's about 10 kilo ohms when it's extended, fully extended, and 0 when it's retracted. But you can use different leads. That's why I'm not using the yellow. You can bridge it with the yellow, and it can be 0 all the way out and 10 kilo ohm retracted. So let me hook it up and just show you what's happening here. Let's see, where's my green lead? Here it is. So right now we are in the fully retracted position, and this is an auto-ranging voltmeter. Right now it's measuring ohms, but you can see it's about 200 ohms. You see the ohm here, so it's about 200 ohms. This is basically, you know, nearly 0 at this stage. And let's hook this up to the power leads. Where are they? Here. And we're gonna extend it and show you what happens when we do extend it. So as you can see, it looks like, I'm reading backward, but it looks like 989 kilo ohms. If you see, oopsie, you see up here, it's kilo ohms, so 989 kilo ohms. So basically, it's 10 kilo ohm all the way retracted. Now, if we reverse the leads, you know, we can stop it, like, say, I don't know, halfway down, for instance, and let's just, well, maybe a little more than half there. But you can see that's a little more than half, and it just went down to about 4 kilo ohms. And if you keep running it all the way down, I was just gonna go back to hardly 0. This was a couple hundred before. Yeah, see, about 200 ohms, no kilo ohms. So the cool thing about this is that you can interface this unit with an IFES system, and then you can display resistance value as position values of the shaft and of the speed brake. So you could have an IFES system that shows a flap fully deflected, and you say it's going to be fully deflected at 10 kilo ohm, and a flap fully retracted when it is 200 ohm. And that way you can have an indication on your cockpit exactly where the speed brake is, you know, in relation to the airplane. Fully closed, fully open, halfway there. You can have it a continuous variable indication of where the speed brake is, and that's very cool, especially since you don't have to have any external device mounted on the shaft to be able to know what the position of the speed brake is. So I think this is a super cool feature, and I'm really looking forward to using it in the future once we get to the instrumentation part. That's definitely something that I want to be able to see, and I want to be able to know what the position of my speed brake is. Anyway, I'm glad I remembered to do this section because this is a very cool feature, and I just hope you like it. And again, if you are interested in this kind of speed brake, not speed brake, but actuator for the speed brake, I bought it at Servo City. The unit number is HDA4-50. It's about $130, and as far as I can tell, so far it's well worth it. I like it. All right, thanks a lot.